All right, we're picking up with the beginning of our solutions unit. So you need to make sure you take the notes over the solutions unit. I'm going to break this down into 3 videos. One for matter is pure mixed compound element, heterogeneous, homogeneous mixtures. Another one's going to be broken down into solubility curves. And then the last video will be pH, acids, and bases. All right, so first thing, in your notes, you need to copy this down. There's some gray boxes, and so I want you to write above the first gray box the word matter, and then I want you to add on, can it be physically separated? So, can matter be physically separated? If the answer is yes, then it is a mixture. If the answer is no, it's a pure substance. And so, when you look at a pure substance, it is either chemically decomposed, which makes it a compound, or it can't be chemically decomposed, which makes it an element. So some examples of compounds, meaning I can break it down a little smaller, would be NaCl, okay, and it says it has a fixed ratio. The ratio for sodium to chlorine would be 1:1. If I looked at H2O, I have a 2:1 hydrogen to oxygen ratio. All right, elements include iron, Fe, hydrogen, carbon. I have oxygen gas, which is O2. Now you might say that's a compound. Well, compound has to be different. So this is the same thing. It just has to be different. So this would be an element. Okay. Going over and looking at mixtures, is it a uniform composition? Well, what that means is, does it have the same composition throughout? So if you look at a homogeneous mixture, homogeneous, the prefix is homo, which means the same, which you might have heard of homozygous. Hetero means different. Okay, so make sure you copy all this in your notes. You don't need to know these bottom 2 words. Okay, so homogeneous mixtures would include coffee, sweet tea, air. I can't see the individual parts of them. Heterogeneous mixtures would include fruit salad, potato salad, Lucky Charms, pizza, chili, things you can see the individual parts. Let's go back up here. Can it be physically separated? Can you pick apart or do something physically to separate them? So a mixture you can, even a homogeneous mixture. So if I have lemonade, I've got the powder and the water, and that makes lemonade. I can get the water out by going through and boiling the water or evaporating the water. It's still the same substance, it just looks different. So I can make the water go into water vapor and I'm left with the powder. Okay, so make sure we have this. Next thing I want to look at would be, here's another example. So you've got 4 boxes on your paper. Make sure that you get the examples of them. Now I went and listed the examples, so make sure if you need to go back, I want you to write examples of homogeneous, heterogeneous compounds and elements in those 4 blank boxes. All right, and now our notes are really going to start. So pure substance is a sample of matter that has definite chemical and physical properties. Every part of the given substance has the same properties because a pure substance is a fixed uniform composition. So table salt is always going to be NaCl. Sugar, glucose would always be C6H12O6. Okay. Elements and compounds are pure substances, not mixtures. So they're pure. You've got pure gold, you've got pure water. All right, so here are some examples. So I want you to pause the video and see if you can tell me if this is an element, a compound, or a part, it should say part of an atom. Carbon is an element, proton, part of an atom, aluminum, element, water is a compound, neutron, atom, sugar, compound, electron, atom, salt, compound, iron, element, glass, compound, copper, element. Okay, so now we get into mixtures. And so mixtures are either heterogeneous or homogeneous. And so what a mixture is, it's 2 or more substances that are mixed together. They keep their chemical and physical properties. So if I make fruit salad and I use bananas and apples and oranges, there's still bananas, apples, and oranges. Nothing new is going to be created. It's just the same substance mixed together. So if we look at the air that we breathe, I've got nitrogen and oxygen and other gases. They're still the same gases, they're just in a mixture. Okay, so let's look at heterogeneous mixture first. So heterogeneous mixture does not have a fixed composition. I can see the individual parts, meaning every spoonful will have a different amount of each component. So if I take a spoonful of Lucky Charms, I might get 2 marshmallows in one spoonful and 10 in the other spoonful. It's different. Same thing with dirt. There's going to be different things no matter where you go in your yard. Okay, it's not always going to be the same. Fruit salad, and then granite is a heterogeneous mixture. It's a rock, but I can see the different components in the rock. Okay. Looking at homogeneous mixtures. Okay, so homogeneous mixture, it is the same throughout. Right, one substance has been dissolved into another. It's also known as a solution. So if I make coffee, I use water, I use coffee grounds, and I mix them together. Okay, that's a solution. Salt water is a solution. Okay, now this is important. All right, so there's two parts of a solution. You have your solute, which is the substance that's being dissolved. So if I'm making salt water, salt would be my solute. And then you have a solvent. That is what is doing the dissolving. And it's always going to be present in a greater amount. I'm not going to make lemonade with powdered lemonade and put more powder than water in there. Okay. Then we talk about concentration real quick right here. So if you look at this, and the blue is the solute particle and the red is the solvent, this is really concentrated because I have a lot of solute present. And then notice I diluted it down by adding more water or more solvent, which in this case is water. So notice it's a lighter blue. So dilute means it's a little weaker. So if you get the Mott's for Tots apple juice, it's much weaker, meaning watered down than the other is. If you drink Coke with ice in it, and then you let it sit for a while, it becomes very watered down and it's diluted. Okay, so examples of homogeneous solutions would be salt water. So let's talk about the solute and solvent. Solute would be salt, solvent would be water. Soda, okay, soda has a couple of solutes, but one of the gases would be carbon dioxide and water. Coffee grounds, and water. Notice I'm saying water a lot as a solvent. Air, we'll talk about air in a minute. And then metal alloys. So earlier this semester we talked about an alloy as being a mixture of two or more metals. Okay, so miscible is two or more liquids that blend together to form a solution. So if they mix together, it's miscible. Salt, water, that's one. Then there's two or more that are not, that would be immiscible, two liquids that do not blend to form solutions. So a good example of that would be oil and vinegar. They're not going to blend to form a solution. They're going to separate. Okay, solutions are not always going to be a liquid. Amalgam is mercury dissolved in solid silver. That's used in your tooth fillings. Okay, there's an example. And then the other example would be the alloys. So you got solids to solids. So brass is an alloy, bronze is an alloy. All right, some more examples would be granite. It's heterogeneous. Human blood is heterogeneous. I can see the individual parts, your red blood cells, your white blood cells, your platelets. And then copper 2 sulfate. So in water, it's a homogeneous, like you can't see the individual parts. All right, so here's some more examples, and I'll link the presentation too. And so we go on to talk about solution a little bit more. You've got a homogeneous mixture, salt water, two parts. You've got your solute, which is what's being dissolved, and the solvent, which is doing the dissolving. Water is called our universal solvent. Okay, water is the universal solvent. It's found in almost everything. So think about all the drinks. Your Powerade is water. Coke's made of water. Okay, it makes up 2/3 of the Earth's surface. Okay. All right. What makes solutes dissolve faster? Now, I asked you to read the article last night, so make sure that you've read it and defined it. But a larger surface area. Okay, larger surface area means the particles are smaller. So smaller particles, they're going to dissolve faster. than the big ones. So small pieces have a large surface area. Like a sugar cube has a small surface area. Less of the sugar is exposed to the water, so it's going to take a little bit longer to dissolve. Agitation, which is another way of saying stirring or shaking, is one way to make things dissolve faster. Adding more solvents, heating something more. Remember, things heat more. It helps increase the solubility. And now this is of a liquid. If you cool down a gas, it actually increases solubility. Okay. So here's your example about surface area. All right. So solubility is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. It's going to vary with temperature. So if we look at this chart, most go up as temperature increases, except for a couple, and it goes down. So we would assume that this would be a gas. Okay. Now, we're going to talk about real heavy on vocabulary. So soluble, anything that dissolves in another substance. Salt dissolves in water. Insoluble, something that does not dissolve in another substance. Oil is insoluble in water. Okay. Now your next one, unsaturated, on here it says has less solute than the maximum amount that will dissolve at that temperature and pressure. In your notes, it says more solute can be dissolved in the solvent. That is the note that you need to take, where it says unsaturated. In your notes, it says more solute can be dissolved. So it's less than the maximum amount. Saturated solutions, no more solute will dissolve in it at that temperature and pressure. I can add, if I add one more granule, it won't dissolve. If I add one less, I can add one more and then it stops. It's the maximum amount that is allowed. Okay. And then super saturated, it contains more solute. And when it contains more solute, things start to crystallize. So this is how rock candy is made. Keep on going. So concentration, copy this down. If I'm looking at this as far as concentration goes, remember up here on the right, I have a super concentrated, look how red this is, and then I dilute it by adding more solvent, and now it's not as red. Okay, so dilute would be a weak solution. Here's some others. This would be concentrated as it was saturated. My concentration, super saturated, goes up. So unsaturated, I can dissolve more solute. Saturated, no more is going to dissolve. And then super saturated, it becomes crystals. Right? And then the last thing for this little part, temperature and pressure affects the solubility of gas. So if you increase the pressure of a gas, it actually increases the solubility. If you decrease the temperature, it decreases the solubility. And what I want you to do is I want you to pause the video, see if you can list the solutes and solvents of these four things. Use this graph for air, and then come back and check your answers. Okay, so answers for that are right here. Okay, so salt water, solute, salt, solvents, water, soda, gas, carbon dioxide, and water, acetic acid and water would be vinegar, and then oxygen, if I look at this chart, would make up less, so it's a solute, and then nitrogen would make up more. All right, so this is all for part 1 of our solutions solubility and pH unit.